Welcome to The Explainer. Today, we're taking a sledgehammer to one of tech's absolute favorite fairy tales, the myth of the lone genius. We're going to completely tear that illusion down by exploring the true, honestly mind-blowing story behind Gary Kildall's creation of the CP/M operating system. As you'll see, his structural breakthroughs laid the actual, literal foundation for the entire personal computing revolution. Okay, let's dive into this. Think about it for a second. If geniuses aren't just magically pulling ideas out of thin air in a total vacuum, how exactly does human progress work? How do we build things that have literally never existed before? It's a massive philosophical question, right? But the answer is actually incredibly practical. Mark Twain gave us this absolutely perfect, poetic metaphor for how innovation truly works. He called it a mental kaleidoscope, and I love this. He said you take the existing knowledge, you give the perspective a twist, and suddenly those exact same colored glass pieces align into an entirely new, breathtaking pattern. You literally need the old pieces to make the new pattern. So the crucial point here is combinatorial creativity. Sociologists and cognitive scientists totally agree that creativity is almost never just an isolated spark. It's a deliberate, cumulative rearrangement of what's already there. It's the act of reaching into the massive shared database of human knowledge, pulling out specific items and synthesizing them. This completely replaces that romantic myth of inventing something out of absolute nothing. Section 1. The Lone Genius Myth and Computational Creation. The history of technology is so often told as this series of dramatic corporate negotiations and lucky breakthroughs by solitary heroes. But that 19th century romantic author model, the idea of a lone genius creating entirely original work, it just doesn't survive contact with reality, especially in computing. In computational environments, creation is always pluralistic. It relies on a huge, complex web of programmers, pre-existing code libraries, strict hardware constraints, and intense collaboration. Cognitive scientists Jill Fauconnier and Mark Turner call this process conceptual blending. They explain that you take elements from separate input spaces, meaning existing separate ideas, and you project them into a common blend space. The result? A novel, emergent structure that simply wasn't present in either input space alone. It's proof that all creative work builds directly on what came before. Section 2. The hardware bottleneck of 1970s computing. Let's look at the specific glass pieces Gary Kildall had to work with. Let's quickly trace this timeline, because it's fascinating. In 1972, Gary Kildall develops the PL/M programming language for Intel. By 1974, he's actually simulating his CP/M operating system on a mainframe timesharing network. He's writing the code before the physical hardware even exists. Crazy, right? Then, later that fall, using a custom controller built by John Torode, they get the very first successful boot of CP/M on a microcomputer. And then, in 1976, a major hardware crisis forces his ultimate breakthrough. To understand the stakes, let's contrast the agonizingly slow reality of the 1970s with Kildall's vision. Back then, microcomputer development was painfully sluggish. Programmers were writing software in hardware-specific assembly language, backing it up on incredibly slow paper cape readers. Just brutal. But Kildall saw IBM's new 8-inch floppy disks, which were a lightning-fast 3,000 times faster than paper tape. His vision? A completely hardware-agnostic software ecosystem, where microprocessors could actually develop their own software, totally free from those rigid, slow hardware constraints. Section 3. Combinatorial creativity in action. Let's look closely at how Kildall actively practiced this to solve that massive computing bottleneck. Now, what's really interesting about this slide is the sheer variety of input spaces Kildall combined. Look at what he pulled together. The Intel 8080 microprocessor, IBM's lightning-fast 8-inch floppy disks, his own portable high-level language PL/M, and John Torode's custom hardware controller. None of these were created at the exact same time, but Kildall brilliantly brought them all into a single blend space to create his operating system. And his process for synthesizing all this was incredibly tactile. Picture this. In his Pacific Grove workspace, he would lay massive 12 by 18-inch sheets of sprocket-hold printer paper across a door blank supported by sawhorses. He'd draw these elegant, comprehensive pictures of his data structures, just staring at them for hours to refine their logical connections. And once he finally saw the pattern, he'd enter a manic coding state, sometimes programming for up to 20 hours a day to make it real. Section 4. The BIOS Breakthrough and a True Paradigm Shift. Here was the catalyst that changed everything. In 1976, a consultant named Glenn Ewing approached Kildall. IMSI Incorporated had just shipped new disk subsystems, and they desperately needed an operating system. Now, up until this point, adapting software to new hardware meant a grueling, brute force manual rewrite, just starting from scratch. But Kildall, he flat out refused to do that. He sought a universal, combinatorial solution instead.
Let's move to and see how this builds. To solve this problem, Kildall executed a brilliant structural separation of concerns. He split CP/M into 3 distinct layers. Step 1, the CCP, which acted as the user-facing command line to process inputs and launch programs. Step 2, the BIOS, the logical file system that securely managed file naming, reading, and writing operations behind the scenes. And Step 3, the BIOS.
This third layer was the absolute game changer. The BIOS, or Basic Input/Output System, concentrated all the messy, machine-dependent hardware interfaces into one modular layer. By doing this, the logical operating system and the user applications were completely isolated from the specific hardware they ran on. I honestly can't overstate this. It was the ultimate paradigm shift in computer science.
Section 5, the first open system and its massive industry impact.
We really have to juxtapose this against the old world. Before CP/M, proprietary mainframes operated like an agentic kingship. You were locked into a specific vendor's hardware, their software, and their closed ecosystem. You were basically just a tenant on their land, but CP/M introduced the very first truly open system architecture. Because of the BIOS, you could write a software application once, and it would run on entirely different brands of computers. The manufacturer just had to write a few simple BIOS routines for their specific hardware, and boom, it worked everywhere. This transformed the operating system into a standardized software bus. It literally single-handedly sparked an explosion of innovation, building the entire independent software vendor industry. Why? Because developers finally had a large enough unified market to sell to. It even allowed for hardware brain transplants. Companies like Microsoft built the soft card, literally plugging an entirely new processor into an Apple II just so it could run CP/M's massive library of software, like WordStar. And this brilliantly illustrates his impact. In 1995, the Software Publishers Association posthumously honored Kildall with this exact recognition, citing his creation of the first successful open system architecture by segregating system-specific hardware interfaces in a set of BIOS routines. By modularizing the hardware interfaces into the BIOS, he literally provided the scaffolding for the entire personal computing revolution. Kildall didn't invent computers. He didn't invent the floppy disk. But he used his mental kaleidoscope to combine them in a way that truly changed the world. So, as we wrap up this explainer, I want to leave you with a final, provocative thought. Where will you look for your own mental kaleidoscope? What existing pieces of human knowledge are sitting around you right now, just waiting for you to recombine them into your own legacy? Keep questioning, keep twisting that perspective, and keep building. Thanks so much for joining me today.